Now on, and this compiler design can get confusing really fast. But this one concept, SDD, makes everything much easier. SDD stands for syntax directed definition, and it basically connects the grammar with the meaning. But generally, the grammar just tells us how a statement looks, but SDD goes one step further. It actually helps us to calculate the values while parsing. So you are not just reading the code, like you are understanding just what it means. And here are the three main parts: grammar, which is defines the structure, and the attributes, which stores the values, and the semantic rules, which tells us how to compute those values. And put this together and parsing becomes meaningful. And now the most important part, attributes. And these are the just values that are attached to the grammar symbols. Here are the two types: synthesized attributes and inherited attributes. The values that come from the child nodes to and move upward, those are called the synthesized attributes. And the values come from the parent or siblings and move downward, those are called the inherited attributes. If you remember this direction, like half of the topic is done. So and now let us understand with a very basic example. Here the 2 plus 3. So we use the grammar rule like E tends to E plus T. We build something called like a parse tree. Now we can see here a tree. Look at the bottom. We have the values and 2 and 3. And these values move upward using the synthesized attributes. And at the top, like we apply the rule, E dot value becomes E dot value plus T dot value. So the final result is 2 plus 3 equals of 5. And that's how the SDD works step by step. So what actually happened here? First, the leaf nodes got their value, and then those values are moved upward, and finally the roots are computed. So the result is displayed. And to organize all this, like we use something called an SDD table. Each grammar rule is written with its attribute and its semantic rules. For example, here we can see that E tends to E plus T becomes like E dot value equals of E1 dot value plus T dot value. And the semantic rules are just a formulas, but they define like how they are calculated, like the addition, multiplication, or even passing type informations. And there are more two types of STDs, S attribute and L attribute. Only these attributes uses like synthesized attributes, so everything moves upward. And the L attribute uses the both synthesized and inherited attributes. And this is not just a theory. SDD is used in the real life compilers for the type checking, code generation, and symbol tables, and for evaluating the expressions. So yeah, that's SDD in a simple way. And once you understand this, the compiler designs become much easier.